Welcome everyone. Thanks for coming to this kind of the kickoff events for TILOS for the new quarter. What we're going to have today is a really exciting conversation of the implication of the rapid development of AI, especially in terms of to the role of a theory. Okay, and we have all recently witnessed, large language models, especially ChatGPT, the remarkable leap that they showcased in the capability of AI. And there has already been a lot of discussions on the broad implication to our society. I think this is really exciting and bring a lot of new opportunities and also new challenges at the same time. This also requires us, as especially a researcher in some sense, to stay open-minded, but also maintaining the critical thinking, perhaps also rethink about some of our research directions approaches. So that's why I'm really excited to see that our TILOS team member are going, leading this conversation on a very timely topic of the role of theory. And we're going to hear from 4 panelists from very different backgrounds. So they're going to bring in different perspective to this conversation. So let me now pass this to Arya Mazumdar, who is the Deputy Director of TILOS, who himself, he will be moderating this conversation. And Arya's own research, he's broadly interested in information theory, as well as connections to machine learning. So Arya, the floor is yours, and all the panelists.
Thank you, Yushu, and thanks all for coming to this fireside chat. I was trying to figure out why this is a fireside chat. So at least at the last moment, I got myself a hoodie, go and have a cup of coffee, and put a background where there is a AI-generated image showing fire engulfing the world. Anyway, so we do have. So I am Arya, and as Yushu said, I work on information theory in general, and I'm interested in statistical inference, statistical learning theory, and their connections to information theory. We do have 3 other TILOS members who are joining us today. Professors Misha Belkin and Javidi from UC San Diego, and Professor Nisheeth Vishnoi from Yale University. I will just pass this first to Misha, then to Tara, and then to Nisheeth, just to give us a 1-minute intro about what exactly are you working on.
Thanks, Harry. Yeah, so I've been working on various aspects of deep learning for some years now, and obviously it's become very clear recently, the last 10 years or so, that deep learning was this very powerful technology. And I think what we have seen in last year really is quite unprecedented, and it's completely, the power of these models have become completely mind-boggling. And the thing that they do, like personally, I would have never expected this to work. Even maybe 3 years ago, it was unthinkable that they would do things that they do. So what I've been trying to do and kind of concentrating on is really trying to understand what is driving the systems and how can we get some theoretical understanding or theoretical insight, because a lot of work has been empirical. And we have these magical machines, which we don't really understand how they work. So, our goal as scientists is to understand their functioning and hopefully to be able to control them and guide them in proper ways. I'll pass the microphone.
Tara.
Yeah, thank you, Arya. So I have been coming at the generally AI from the perspective of AI for engineering, in the sense that I've been really interested in situations when data is more expensive than not, and you want to be clever about how to collect your data to sort of enable more powerful models. And so in that context, last year has been quite, consequential in the sense of the ways we have been thinking about this, because it shows in one sense, as Misha said, what these models can do that we didn't expect, but also what large amount of data can do. So it sort of pushes the pressure more to think about, what if you're in scenarios where data is expensive, truly expensive, how would you think about complementing and sort of bring us to that level? So this is the kind of work that I'm doing, and it's really been disrupted by this. What can you do with these larger models that have been learning on large data, and can you sort of try to complement the scenarios where data is expensive? And I'll pass to Nisheeth.
Hi, everyone. Thanks, Yusu and Arya, for the introduction and for organizing this panel. So my name is Nisheeth Vishnoi. I traditionally have worked in theoretical computer science and optimization. And in the last few years, I've been looking at various aspects of AI, for instance, emergence of intelligence, bias in algorithms and artificial algorithms, and also the issue of privacy. All of these problems, I think, have become significantly interesting in the last year or so. And I must say that there is not only an existential crisis for society at large, but also for academics such as myself. Every morning, I think, what should we do? And I guess nobody said that, but I will be. I will start by saying that I'm sure many of us feel like that. And I think this panel is really a convening and hopefully will address potential future directions. So I'm looking forward to it. Thanks.
Right. So I think the status of AI as a science, it's a bit unclear, because recently Time magazine published a list of 100 most influential people in AI. And it's amazing, because you cannot think of 100 most influential people in physics and just put there some astrologers and some science fiction writers, journalists, and doomsday cultists. So it's really your YouTube influencers even. So that says, like, okay, so what should we do so that AI become a proper science? So is this theory, is this in this status because the understanding is somehow lacking, and is theory is going to bring that understanding in AI? So what would the theory of AI would look like? I mean, and I think any of you can pick this up, and maybe we can take turns. But when we say theory of AI, what exactly that mean? What are we aiming for?
And now for something completely different, because I'm approaching the problem in a very different way than what I heard all of you deal with. I've been engaged in the AI space for years, really most notably starting with the Watson Jeopardy work, and then some work we did with NASA on the mission to Mars, trying to build a HAL like I have back here, but minus the homicidal use cases. That's something the customer didn't want for some reason. But the last 5 years, I've been working not so much in the space of computer science, but in the space of neuroscience, and have been engaging with a set of neuroscientists to better understand the architecture of the brain. Now, obviously, artificial neurons are a whisper of what the brain does. Artificial neurons are very much not like the neurons in the brain itself. We have spiking neurons in our wetware here. There are many different kinds of neurons. We have glia cells that interact with them. And even though the European Union Brain Project is on the verge of mapping the entire brain connectome, just because we have a wiring diagram of the brain doesn't mean we understand how the brain works. Indeed, there has been a complete representation of the neurology of many different species, a common worm, the fly, about a dozen of them have done so. So we know that even though we can see the structure and we understand the chemistry of the things at the end, there's something in the middle missing. Contemporary AI has landed upon a particularly interesting architecture, namely transformers, which are, as Timnit Gebru often says, leading you to a stochastic parrot. That's fine. But I think the neuroscience community is beginning to help inform us to new ways of looking at it. The ideas of global workspaces, the notion that there are these micro patterns, such as within all of us, the sheath around our brain has about 6 or 7 neurons deep, forming cortical columns. The good folks at Numenta are exploring that. So while I think that AI is in an interesting place, I'm going to go out on a limb and say that I fear we are at a plateaued minimum for the moment. It's an interesting minimum, economically interesting, valuable in some ways, but there's so much of the industry focusing upon this with its funding. I fear that we're missing things that might go beyond that. So that's where I'm spending my time, in the great unknown. I should break out into song from Frozen 2, but I won't do that here. By the way, I noticed your Fireside thingy in the background, and I brought my own fireplace, those who didn't notice here.
That's great of you, Grady. Yes, others, you want to address the question regarding role of theory, or what the theory would look like in AI? Is it?
Sure. The thing is, we don't really have a good theory. We have some ideas of theories. We have whispers of theories, but I think we are a long way away from even having a testable theory as to what that might mean. Look, for example, at some of the quote theories around integrated information theory. There was a great paper, 120 other folks basically blasted it as pseudoscience. I don't think it's pseudoscience. I think they have some interesting hypotheses. It's different than the ones we've been talking about here. But even so, the essence of any kind of meaningful testable theory is that it is indeed testable, and integrated information theory is a way for that. So I think what needs to happen, so I'll leave it at this. I think we are lacking good theories. And I think that those theories can probably be best informed, not by us computer scientists staring at our navels, because I think we're too focused upon things like transformers, but rather a more interdisciplinary view of the world to say, wow, we can be informed by understandings in psychology, in theology, I'll even dare say, in neuroscience and the like. That's where I think the theories will come from, because I'm not sure we have a good one right now.
Nisheeth or Misha or Tara, you want to take it?
Yeah, so first I would like to go back to your comment about the time 100 list. Actually, one of my ex-students is on the list, so it's not just...
I'm pretty sure there are some
yeah,
good people in the list.
but I take the point, and I think building up on Grady's point, about the role of interdisciplinarity and theory, I think this becomes even more important in the current scenario. I guess if we take this analogy to neuroscience, to AI, it would be like the following, that if I give you my laptop and you can make any measurement of temperature, energy, electric current, resistance, from that, can you figure out the algorithm that is running on it? How many people here think that? So I think we have to think a little bit more structurally about what is happening. And I think the most important for me personally is what is really fueling this research is humans at the end of the day, the human generated data and the human feedback that has been used in the refinement of these foundation models. And I think this is where I personally would like to focus, and I would like to mention some opportunities that theory oriented people such as myself can contribute. Transformers are today, there will be something else tomorrow. I do not think transformer architecture is something very remarkable. I think it's the data And I think, as somebody said, that nothing in biology makes sense in the, without the light of evolution. I think something similar can be said about AI. So understanding data, developing models of human generated data, which includes language, images, and so on, I think is very important for us to make progress. And I think here we can take an optimization viewpoint, even though each individual might feel very different. I mean, there are 7 billion, 7.5 billion people on the planet. Each one thinks of themselves as very, very different. However, if you talk to people who manage people, there are these books which will tell them that there are 16 personality types or 32 or 100. So there's not so much diversity in terms of the algorithmic processes that are generating data. And even if there is, I think what is probably determining the outcomes of these foundation models is some statistical properties, something similar to this room where there may be trillions of molecules, but I do not need to understand each and every molecule to understand the temperature of this room, or how the temperature is evolving, and so on and so forth. So I know, Misha will have probably more to talk about, and I would also like to hear Tara and others, comment on this.
Right. I think, Nisheeth, that's great. And I just want to underline one thing. You said that transformers may not be the special, something special. There might be something, 2 years down the line, which would be the next thing. So when Tara and Misha, can you also address this? Do you think this attention model, is this some lottery that we have hit by chance or by design somehow? Or do you think that this is just one of the regular things that it's going to get changed in a couple of years, like Nisheeth said?
So for me, what you mentioned about this timed list is also a reflection of the need for us, the academics and theoreticians, to really insert ourselves a bit differently in this conversation. One thing that has bothered me more than who is on that list, which I take your point very much close to my heart, is this understanding of general intelligence in biological processes versus the understanding of the models that are successful at this point of time, be it transformer or large language models or whatnot. So I sort of we have had this conversation. I think Misha poses it a little bit more eloquently than me, but I think to some extent I'm really hopeful that we all come to this thinking about this is a human build technology, and we should expect to understand it far more than how we understand general intelligence. And that will sort of bring our expertise and focus a little bit more into the more positive phrasing of what we think of modern AI. When you equate it with things that are like, harder and less experimentable, I feel like we're shooting ourselves a little bit in our foot. We are all very, all have been hit by this wave, the new wave, and how we didn't think it would be here. But it doesn't mean now we should be as, in the long term, be as puzzled about it as we are puzzled about various biological processes or intelligences as a large. I would like to say, let's do a theory. This is much more focused on why this is doing something we didn't expect. So going back to what Nisheeth said, what kind of data is generated to allow us to do things that statistically we thought are not, they're going to overfit, or they're going to do this, all of these questions, try to understand and correct our own theoretical understanding of what learning a model really means. That's the kind of a much more, I think, focused view of theory that I would like to bring here, to say this is a technology we built, and it's unprecedented to say that we don't understand it, even though we don't understand ecosystems and brain and all sorts of other complex natural phenomena. So I'll just stop here.
So maybe if I can follow up on Tara's point and Nisheeth, and also I think I somewhat disagree with Grady's point that I think at this point, what we see is that the system's remarkable capabilities actually probably have. It's not like we need biology to understand the systems. I think we need the systems in order to understand biology, cognitive science, and maybe even theology. It's they actually shed a lot of light on what it means to to be what cognition means, right? What it means to understand language, what it means to be able to do these tasks, which until recently we thought sort of were uniquely human. And I think we can have theory, sort of to address the question that Arya Nisheeth brought up about like whether it's is transformers the right model? Well, it's hard to say. What is the probably it's not. I agree that there is no like reason to think transformers are in any way optimal, but it is clear that there is some sort of very structured principle of extracting information from data, and extracting the structure from data seems to be a very simple task, right? Because we kind of almost ad hoc practitioners by some sort of iterative process constructed these amazing models, which are incredibly successful, right? This cannot be a coincidence. It's unimaginable that, our human brain, like the people who did it, just stumbled on the right architecture after a few tries, right? There are just so many possibilities. The space of architectures is infinite, essentially. So it means that there is some fairly simple principles, and probably finding these principles is not that difficult, which suggests that theory is possible, right? It's like if you think about gravity, right? Okay, like all these objects in the universe, and it's incredibly complicated, but yet, people were able to discover some sort of very fundamental laws of that. I don't see why something like that cannot exist here for language.
Misha, since you have the mic, and since you have been working on deep learning theory, as you said in your introduction, what is the status of deep learning theory? And through your work, like what lessons can we take from deep learning theory, to explain further things in AI or the current status of AI? Is there any lesson to take there?
Yeah, so I think I kind of feel that the status of deep learning theory is a little underappreciated. And that is because the practice has been so amazing that it's kind of hard to compare anything to this, right? These models went from nothing to being able to speak like fluently in 50 languages in just a matter of like a year or two. But we actually had, I think, very good progress in theory. We understand now some aspects of non-convex optimization. And until like maybe I would say a few years, I don't know, let's say 7 or 8 years ago, we have basically no understanding of why the systems can be optimized. Now we understand it pretty well. We understand now generalization much better. Again, it's not at the level when we can explain LLMs and things like that, but we certainly understand, at least at the first order, what they're doing. We understand much better this things like overfitting, which used to be a very mysterious phenomenon, and now we actually understand it. Again, for much simpler models, but we understand it reasonably well. So I think the progress has been pretty, if not for the practical progress, which sort of exceeded all expectation, this would be an amazing, golden age for theory, I would say.
But I would observe that the theory you talked about are theories with regards to the implementation of particular statistical methods, not a theory of what we see with regards to reasoning, understanding, inference, causality from the human intelligence perspective. So I have no doubt that we have indeed seen great progress in understanding how these black boxes work. But that, with all due respect, doesn't interest me so much, because I think you're focusing upon the optimization of what I called the local minima in AI architectures right now. And so, again, while I think it's useful, I think there's also value in looking beyond those kinds of architectures as well.
Since we are at the fire chat, I'm going to take the fire on, and because in some ways what I'm saying is sort of in direct. I'm saying that these larger theory questions have baffled humans forever. And in fact, when you go there, it's very hard to define what theory is. And that's what it is very different to get a list of people who thought about these very large questions, the most influential people who think about politics or economics or which are far smaller than the questions you're posing. You would get a much more varying group of people than if you ask about the state of physics or origin of universe or sort of things like that. So I want to go back to Arya's and I say it really depends on where we want to land. I would like to see the conversation to focus on these, what you call local minimum theory. I would like us to sort of focus on that and have a more optimistic perspective on understanding this, to be able to focus the conversation a little bit away from these larger, folks that, especially the doomsday, right? Like I'm sure all of us watch the Hill hearings, and we were actually, Yusuf and I were just at this showcase event that Senate was NSF organized for the members, the staffers of the Senate. And it's an important point in history for us to be sort of put in some academic view on this in terms of scientific discovery, cooperation, and these are the kind of things that you learn in those bigger conversations. The absence of academics that can have really major consequence in terms of policy for research. I see Nisheeth unmuted himself. Sorry.
Yeah, I think there is space between doomsday scenario and local minima. And I think that's the space where I would bring the attention to. I think in my perspective, having spent time thinking about deep learning, I never got attracted to the idea of explaining why something works when the explanation doesn't have any further predictive value or usefulness to practitioners. And I think this is something that I would not want to repeat. I'm guilty of starting a very famous blog in which I did not, participate so much of the convex path, which was dedicated to explaining why and what deep learning was. So this was around 2015 or 16. I don't remember exactly. It was a similar thing. Deep learning was working. Everybody wanted to explain. And I felt like we are like these people who are running behind this group of deep learning folks who are making everything work. We are running behind them, say, hey, I can explain why this works. I can explain why this works, but nobody's interested because they know it works. And I think going back historically, when we look at physics, for instance, it's a very good example. In physics, as everybody knows, there are theoretical physicists and mathematical physicists and applied physicists, right? Theoretical physicists have played a tremendous role in the development of physics, starting even from people such as Einstein, whose theories had predictive values, experiments came out of them, which were done by people like Wheeler, and so on and so forth. So I think that's what we should focus on. I mean, any theory that we are doing, we should a priori estimate its predictive value, rather than just trying to say, okay, transformers work or gradient descent works on transformers. Let's try to prove why. I mean, so the question I would ask is, why is that interesting? Why would that be interesting? Well, somebody can say, but while trying to understand, maybe I will come up with a simpler architecture, which is simpler than transformers. That's perfectly fine. But then I would ask them back, is there any evidence of this happening in the simpler world of deep learning? So I think we need to be more critical of ourselves rather than congratulate ourselves on the success of deep learning theory, to be very honest. And I'm sorry, I don't want to offend anybody here, but I'm sure I've offended many people. But I think that's where the discussion should lie, right? I mean, yes, there is local minima and then there is doomsday. The space in the middle is where I think going forward, theory should focus on.
Yeah, I think that's great. I think that's a great summary of the status of thing. And I think we make many of us make a mistake that when we say theory, we mean it in some sort of, I mean, we don't even mean understanding. We just have our pre-definition of theory, which might be a set of hypotheses, which for some people, it might be proving some theorems. But when we are talking about understanding, the practitioners are already understanding a lot. They're making all these systems work, and they're engineers, they're working. I mean, we don't understand, but that doesn't, it will be very demeaning to say that these folks in these companies like Anthropic or OpenAI were making this amazing thing, that they don't understand what they're doing. So as soon as we try to tell them we are trying to give some understanding, of course, they are going to be, I mean, I think we are fortunate that they are not very offended. Like this is, so Misha, since I think Nisheeth sort of challenged a little bit on deep learning theory, so is there any predictive value of the deep learning theory, or like is there something came out of the theory that this people can hold on to and say, oh, this can be something we should try out, even if it is not a reality? I mean, are there directions? Sorry to put you on the spot.
Yeah, thanks. Yeah. So maybe first a couple of points. I think it is fair to say that people who are doing practice don't really understand how the things work. I don't think it's demeaning to them. I think it's just the reality of it. And you know, what's amazing is that they have enough intuition. So they have some understanding because they can make the system work, right? But this is a very intuitive. So maybe I sort of follow up on Nisheeth's analogy. If you think about it as some sort of physics, right? And how did the nuclear physics come out? It's because actually they discovered some sort of fundamental laws of physics, right? And then those laws were used to make nuclear reactions, nuclear bomb, things like that. So imagine it kind of went the other way around, and they figured out, you know, pre-nuclear physics, or maybe even pre-Newton, they figured out that, you know, you put some elements together and you get this tremendous amount of energy, right? It's not unthinkable something like that could have happened. I mean, not with real, like, actual nuclear physics requires too much knowledge, but in principle, some sort of alternative universe. And then they like figure out how to use this energy, right? That this energy can be used, but that doesn't mean that they would actually understand nuclear physics. So I think exactly the same thing is happening now, right? They really are very good at figuring out these patterns of the models, but that doesn't necessarily mean that they understand or anybody understand this what's the real fundamental law underlying this. And there must be a law, right? Because we're dealing with something like predicting language, right? There is no way you can just guess this thing. There has to be a fundamental principle. Now, for the language, we don't have anything like that, but we do have much simpler examples when a theory actually tells you something, and so some of our work have been trying to sort of get to it for like much simpler types of data, for like tabular data and so on. But yeah, so I think there are definitely examples when theory helps. It doesn't help, I think, yet for problems which people are really excited about, like really understanding language or really understanding images. But even for images, you would say that convolutional architecture came from some sort of understanding of the visual system or understanding of some sort of basic physics of the problem, right? That you need some sort of parallel transport. You need some invariance by parallel transport. So that's kind of understanding. And personally, I've argued that understanding needs to come more from physical take on this. So having like some sort of laws rather than having, you know, like proving a theorem that it always works up to epsilon or up to delta. You know, physicists don't usually prove theorems, but that's okay. It's still rigorous, right? It's still theory.
So, so this is a really interesting question. As I was thinking, Nisheeth, I guess I see your point about predictive power. Like, really, I would say in the sort of a big academic sense, science and engineering or theory is what gives us the ability to predict. But also, I think this is not very unusual, and it's not a diminishing of the power of intuition and thinking. I would say, Misha talked about the nuclear physics example. I'm thinking about aviation. It is true that for a good part of the beginning of building airplanes, relied a lot on engineers who had good intuitions and built these systems. It wasn't until we demanded certain theoretical guarantees of safety to say, I really want to make sure this airplane does not crash with same frequency, that you really see the power of control theory, sort of this demand for something that the engineers could not provide, and the sort of the demand, can you come up theoretical guarantees? Now, of course, those theoretical guarantees are with respect to some sort of a physical laws and models that themselves are, are built from data. But when I'm talking about predictability, that's what I would like us to have, this sort of a going back and forth between practitioners and theoreticians to sort of together build a predictive power. Right now, I feel like each community by itself doesn't do that. So even the practitioners, even though they manage to do this, they do it through a lot of iteration, which means that they're not waiting for their predictions to be correct. They try to get their hands dirty to see if their prediction was correct, and if it's not correct, they're not afraid of it. They iterate on it. In some sense, I would like to see theory do the similar with a speed of relevance, but your point is well taken. What it constitutes, I'm not sure.
So there are two questions that I have been thinking while listening to Nisheeth, and also I had earlier conversations with him, and then which got me thinking. And of course, you can see since we are drawing parallels with physics, in modern computer science departments or engineering or in statistics, now we have created, this might have happened gradually, like there is a gap. There is a gap between theorists and practitioners, and theorists have cornered themselves into, taking a paper and pencil and like proving something. They don't need anyone else. Whereas if you go to early, 20th century or something, I mean, people like Rutherford or Chadwick, they're also good theoreticians. I mean, even Otto Hahn or some who were actually great experimentalists, but they were also theoreticians. So think of but in engineering, gradually we had we saw with control, which is hand in hand with practitioners, and theorists sort of understand how these systems are going to work, and that's why this has been so successful. We had airplanes, we had all like rockets and everything. Whereas now, I mean, even if I have some ideas, I don't even know, or many of the theorists don't even know how to try it out, because they have never really spoken to these people. They have never really went on and implemented something and saw their theory really works. And I think we have dug a little hole around ourselves in that way, that now even if we want to contribute, I mean, these models are with OpenAI. We just have barely some API access or something. I mean, we don't even have time. It's like we have to buy times into these large models to do something, some experiment, and to grow our understanding. And if we don't have understanding, how can we even catch up? So Nisheeth, Tara, Freddie, or Misha, what is the strategy right now?
Yeah, so I think I heard several questions which I would like to comment on. So I'll go in the order in which I remember them. I think first to Misha's comment about theory playing a role in CNNs, I absolutely agree, actually. I mean, so I started my career at IBM Research, and then I was at Microsoft Research. I mean, in my daily interactions, I would interact with practitioners and they would give me some vague problem. And my task was to make it, somewhat modular, somewhat, and then give some solution. Half of them did not turn up into any concrete papers, but I do think that there were contributions which relied on people such as mine's ability to look at a nebulous thing and make it more abstract out what the difficulty might be. Okay, so taking it in the context of large language models, I think one challenge is, well, what aspects of a language are being used by the learning algorithms and what are not being used, and how can we test them? So, I mean, language is a complex thing. You can view language, and currently the view of the language of these foundation models is that it is a collection of sequences. Right? I mean, that's so if you look at what the base model is, that you have a sequence and you want to predict the next word. I mean, I'm caricaturizing it. It's very rough, but roughly this is what the starting point is. So the question would be, what about a language? I think where theory can potentially contribute. What about a language is being used, and how is it being used by these foundation models? This will be very useful, because I think as far as I know, we don't quite understand very well how to go from language to other forms of input. For example, images, or you can imagine more complicated structures which are not linear, maybe matrices or tensors and so on. So I think coming up with concrete ideas in this domain, even though they may not have the luxury of a fully rigorous mathematical proof, is something that theoreticians should consider. I think mathematics should be the strength of a theoretician and not a weakness, in the sense that I'm only a mathematician if I prove a theorem. I think that is, in my opinion, how currently many theoreticians, suffer from. And I think this has to go going forward. Because if one is hoping to prove theorems about these foundation models, it'll be difficult. But I do think that just looking at a system, abstracting out the principles, understanding what is relevant, what is not relevant, and suggesting alternative models or some insights about data. Now, this doesn't sound all very clean. And as Arya said, this will only come when we actually put our hand and feet deep down inside this world. I think the time has come for that. I think I addressed your question, but if not, just maybe I forgot. Yeah.
Yeah, just a quick comment. I really like Nisheeth's. That's a great line, actually, that mathematics should be the strength of theoretician, not a weakness. And somehow insisting on proving like rigorous theorems every time, it becomes a weakness, right? But we should use it as a tool to analyze the real world.
So I guess we are surprisingly converging to this point of really thinking about theory in a more generic sense. So to just rephrase, a lot of the theoretical proofs that we are kind of attached to, they came out of time where really testing for all possible cases would be, impossible. So at least that in the controls domain, which I'm the most familiar, that became sort of the necessity for theory to just sort of rule out the rare cases and so on and so forth, which testing for every case would have been impossible. But now that we have moved to this new way, I think what we are converging, which I'm happy to hear, is this close connection with the practitioners, but this ability to sort of abstract out and really make predictive statements about what these things are good for, or and there's a couple questions in the chat. I noticed Bijan's comment about if basically this notion of adversarial examples. So that is to me is a good example where we try to really understand from a first principle, or call it theory for the lack of a better word, is where these come from. And that has given us this ability to really, and there are researchers who now have practical and intuitive ways of going after the vulnerability in the model, right? So I think these are, I view this as all the sort of a big capital theory. And I think this is what I'm hearing, is if Arya, if you don't hear the agreement.
Right. Yeah, I think it's yeah, it is a bit surprising that we have quickly converged when we started with Fire.
Yeah.
So I guess there are so I think one question that that you folks sort of like didn't address, and I really want to know is about like, yeah, we understand that we need to get our hands dirty and like we have to sort of do these things, but okay, so let me step back. So this is a very impressive software. Like if you see ChatGPT Plus, it's like it's amazing, but as are you all like it's very surprising, but is it completely unexpected? Is it completely mind-boggling? Is this it, or do you think that I'm sort of putting like sort of open-ended?
No, I don't think it's mind-boggling. I mean, I use it a lot, and I can tell you it can't, I mean, do simple things. And I mean, I guess there is a very nice talk by Eugenie Choi from University of Washington, who gives this example of multiplication. I mean, I was in a restaurant that day, and I have a hard time calculating tip, and I asked it, how much should I tip? And it just gave some nonsense answer, based on the so it's not at all mind-boggling. It's not reliable. I think its current utility is limited, but still valuable enough to create economic growth in the sense that it can further or speed up computations which traditionally were being done by human labor of certain type. I think that's where I would say. But
The phrase I'd like to use is that large language models are unreliable narrators. And I'll go so far to say that by the very nature of their architecture, they are incapable of understanding, reasoning, or abstracting, but they can mimic that. And it's the mimicking that can be indeed economically valuable. But back to the unreliable narrator, one has to be careful about how one uses them.
So my
Yeah, I would. I actually, I guess it's a different take. I would say so. Well, it would probably get us too deep into a philosophical discussion, but I don't think they mimic. I think they actually they exhibit the same signs of intelligence that natural intelligence does, and I think that's as far as we can take this because we don't know how natural intelligence works either. So, and to me at least, okay, whether it's mind-boggling or not, it depends, of course, on your prior, but to me, it was extraordinarily surprising, and in fact, I was extremely skeptical of it as recently as like a few years ago. I said, okay, there is no way these models can get us to some sort of artificial intelligence. This is clearly not going to work. There is not enough data in the world for this. The statistical models are too simple and so on. And I think I was completely wrong. So, I mean, in that sense, it was extraordinarily surprising that you can converse with them fluently in, 50 languages. Well, I cannot converse with them in 50 languages, but I can convert them with like in English and, whatever, right? And they give you reasonable answers. They're not super reliable, that is true, but neither are people.
I think the thing
so
that yeah, finish your thought.
Sorry, yeah. Let me just add something to this question. So for me, two things that your question brings up and the answers. One is the emphasis on the theory that explains something cannot be done. So in information theory, we call them converse. Almost every theoretical field has something, lower bounds or whatever you call it. So I think even when we say it cannot do X, as an academic, we should get in the practice of even trying to even do that predictability a little bit more carefully. And that, in that sense, I agree with Misha. This reasoning is hard to define. I would say that I thought with the current data, it would be hard with this amount of data to learn a model with this amount of parameters to fit and do. So in that sense, it's mind-boggling. And I go back and I view it in a positive sense that they have some structure, the language itself, words have structure that this has recovered that was not just haphazardly. I thought it would happen. So in that sense, I share with Misha. And going back to Nisheeth's example, so one thing, I teach the theory courses in ECE, and we kind of historically have said, it doesn't matter if you got the right answer, the arithmetic correctly or incorrectly. Give me your explanation about how you are thinking. And then now, if you think about now ChatGPT giving this explanation and does something really terribly wrong with the arithmetic, the explanations have been surprising, the kind of thing that I would give partial credits to my students quite often. So in that sense, it's made my life harder when we think about like integrity questions. So in that sense, it's mind-boggling, and I worry about it. I teach probability this course, stochastic process. So I was never worried about cheating, because I always thought when people in isolation explain what they have done in this problem, I sort of get a sense if they understood or not. And now I am like, if they're just repeating what ChatGPT said, I really have lost my ability to help them in some sense. So I just put it in that sense. It boggles my mind of how I would teach my stochastic process course this quarter, even though arithmetic, they never managed to get it right after the.
So I think we will wrap up soon, the interest of time, and we will take some audience questions before that. But let me summarize what I heard from the 3 or 4 of you. And I think on one hand, it's true that we do not understand human intelligence completely, and therefore there has been a moving goalpost. And maybe some of us would never really be satisfied, because we would say, oh, but this cannot do this. But on the other hand, it's also probably not as mysterious as a monolith on the dark side of moon that, like, even we are completely surviving and we have no explanation of how that has happened, right? So it's probably very much within reach. Nothing really alien happened in the last 3-4 years that would require completely new math or completely new understanding of the universe. So yeah, I guess both of these two can be simultaneously true. And with that, I think we should take a few questions from the audience who have been so patiently listening to us for the past 50 minutes or so. So if there is I think Grady has some questions that I see in the chat, if you want to speak out, or Armin wrote some. Yeah.
I had no questions, just some comments along the way.
Sorry, I have not been keeping track of the chat, because also had to listen to what people are saying here. So any question for our panel?
So this is Armin here, Armin Schwartzman. So I was thinking of a simpler example, maybe to compare the language models. It's a question of whether they can understand and not understand. And I can see different answers that maybe you can speak to. So suppose that you teach a machine very simple program that knows the multiplication table, right? How much is 5 times 6? They give you the answer, right? Give you 30. It's very similar, right? Same idea. Doesn't mean that they understand how multiplication works. Well, they don't, right? But they work in practice. And so does it matter from a practical point of view? It does not. But does it even help us from a theoretical point of view, understanding how this machine encodes the multiplication table? I just wanted to bring that up as an example. It's a simple way of understanding these models. Misha has an answer. Grady too. Tara.
Yeah. I think, Armin, what you said is exactly what obsessed me, and I said it less intelligently, which is if you teach multiplication, the theory would say you will just take these numbers, you're counting how many of them, and then you teach them this sort of idea. So if somebody forgets the multiplication table, they can sort of reason through it. They make mistake computationally, and that's what I have been grading as, oh, they learned it, they made a computational mistake. So we distinguish these things, and your example is exactly the kind of things that I find, like this use of this explanation is now suddenly very different from actually doing and following through the procedure.
So let me just since I mentioned multiplication, I don't want the discussion to just kind of focus on that. I think there are many different examples of this type. For example, if you try to ask a chat GPT or GPT-4 about some person's birthday, now it's not doing any calculation here, but it really depends how you ask the question. And I think this raises a very nice avenue for theory. Before, when we were designing algorithms, the inputs were fixed. I mean, that there was a specific format in which you would ask, you want to sort n numbers, you give n numbers, and the output is n numbers, which are sorted. It is no longer the case. I mean, the question that you are, so if I want to know the birthday of Albert Einstein, there is no one way to ask that question, and the answer is surprisingly different depending upon how the question is asked. This is, I think, somewhat unprecedented, and it has led to this whole area of prompt engineering, which I guess many of you, I mean, that's pretty much all academics can do, either prompt engineering or, but I think focusing on trying to understand the failures and seeing how we can, what is language at the end of the day? When we ask a question, what does it mean? It's not about understanding, it's in how many different ways can we represent this question, and then check, what kind of answers do we obtain? And if the answer probability is varying so much depending upon the representation of the question, then how can we design these systems to be more robust with respect to questions, irrespective of how they're asked? I think, yeah, so I think for people whose mind is boggled, I suggest, just incorporating it more and more and looking around more for such examples. It's not just multiplication. It's like in everything that you would imagine. So for example, here is a question you can try asking. So if you give a paragraph from Shakespeare and ask it to predict the next word, it'll predict with 100% accuracy. But if you give 99 words and ask it to predict the first word, it will do it with very low probability because of the sequential nature in which it's being trained. And I think these are major failure points. How can you trust this technology? What does it understand about Shakespeare? It is not just about multiplication. I mean, I think so. So Tara, going back to your, would you give partial credit to people? If you're asking questions, okay, a sentence is A, B, C, D, and you have to guess what E is, as opposed to E, D, C, B, and the answer, it's your goal is to guess A. These are two fundamentally different, difficult tasks different in difficulty tasks for these language models, but for humans, they are not.
Actually, Nisheeth, I would argue that this is also very difficult for humans. You ask people, like, what century was Einstein born in, and like half of the people would get it wrong, right? I think people don't know such things. They just know that they can check, we can search. That's our ability.
But the people will know that they don't know. That's the difference.
I think, let me just say, people will understand the question that is being asked. I think at this point, I'm making something even more saying something more fundamental, that I don't think these language models even understand the question that is being asked. You may not know the answer. That's fine. I understand that. But do you think you will, I mean, no matter how I ask you this question of when the birthday of Einstein is, do you think people will not understand this question?
What do you mean by understanding question, I guess?
Exactly. I guess that's what the reason I said the class, because we try to sort of get our hands around understanding, right? And if the student gives me an answer that I sort of can decipher, I try to see if they understood or not. And then by giving them sort of the next question or sequencing what the questions ask, I often are helping them to sort of, get to the point of understanding in the way that you natively kind of we're using the word. And that's what I think is interesting, is that now it has taken away my ability to rely on human language to sort of decode, are they getting close to be able to reason in these very simple, follow this pattern of steps to solve a probability problem. Does that make sense?
Okay, so I think we are at the end of our assigned time, but this discussion could have gone on for way longer. So we should definitely do this again sometime. So I guess at the end, we sort of disagree a little bit about the reasoning abilities of or even if there is any reasoning. So of course, and it's hard to have discussions like I think one thing that academicians can do is to have an honest discussion on that, because a lot of money and profitability is riding on this type of questions. And of course, if you go to industry, they are going to hype up. People are going to say, oh no, Sparks or something else. And like, whereas academics can more or less have a more, more down to earth discussions and figure out whether something like that exists or not. Anyway, with this, I thank all of the panelists and the audience for actively taking part on this. Thank you very much. We should do this more often. Thank you.
Thank you, Arya. Thank you, Yusuf, for starting.
Thanks to everyone. This is really excellent.
Thanks, bye.
Bye.
Yeah, this was fun. Thank you.